only running at 998 megahertz. Did I not get my money's worth? No, it's running perfectly. What it's doing is because there's not much activity on my system, it is scaled down and only running at 1 gigahertz speed. And that's exactly the way it's supposed to work. If I started running calculations, performing a lot of video functions, once I start editing this video, for instance, you can bet that this core speed is going to bump up to its full capacity because I'm going to need a lot more processing power to take place to be able to render video or run whatever I happen to be doing on that system. Another interesting thing that we're going to look at on here is something called instructions. You can see a lot of different instructions are written on here. Some you may recognize, some you won't. A very popular one recently was the MMX instruction set. And that instruction set refers to a set of microcode that's inside of the CPU. These are very specialized CPU instructions. And because they've been pre-built into the CPU, they can perform particular functions very, very quickly. They operate inside the CPU at the hardware level. Since they're instructions that are already ready to go, they're very, very fast. A very common one is called MMX. It's one that was marketed a lot by Intel. MMX is a microcode that allowed the CPU to understand more about multimedia processes inside the system. And it was introduced originally with the Pentium CPU from Intel. It stands, well, Intel says that it stands for Multimedia Extension. There have been other pieces of documentation that are referred to it as a matrix math extension. So we're not exactly quite sure internally what Intel's called that, but externally to the world, they simply refer to it as MMX. There's many different kinds of microcode. MMX is just an example of that, but the more diverse sets of microcode that are inside a CPU, the more efficient that it's going to be in performing functions and instructions that are detailed specifically for that type of microcode. So if you got an MMX CPU, it's going to be able to do multimedia type processes a lot better than a CPU that doesn't have MMX. It's a very good example of how microcode can improve the performance of a CPU. When you start working with CPU, you'll find that voltage is a very important piece of this. Different CPUs run at different voltages. Inside of my laptop, because I have that CPU throttling taking place, my CPU can run at different types of voltages all the time. When it needs more power, it asks for more voltage from my system. And it does that through a process called a voltage regulator module. You'll also hear this referred to as a power processing module. That voltage regulator makes sure that the proper amount of voltage is being provided to the CPU. And it knows what is expected because the CPU asks the voltage regulator module to pull a certain amount of memory from the system. And it does that through something called a VID, a voltage identification. The CPU asks what type, says, I need this particular kind of voltage, sends that ID through, and then the voltage regulator module tells the rest of the system to provide that level of voltage back. And you'll see that there's 3.3 volt voltages, there's 1.1 volt. It depends on what the processor needs at that particular time. We'll go back to our CPU-Z and we can see that in fact this particular core VID right now needs 1.063 volts. As the core speed changes in my system, that voltage ID is going to change as well. So you may want to pull up CPU-Z on your system and start getting better understanding of exactly what voltages are taking place inside of your system. If you're working on a platform that is on a motherboard, these days many of the voltage modules are able to dynamically get assigned that voltage, but some of the older motherboards may have jumpers that you set what the voltage is for that CPU that you're putting in. So if you're installing a motherboard with that CPU, you may find that you have to really look into the documentation to understand what voltage that CPU requires and set your motherboard up to use that particular voltage. If you change CPUs, it may need a different voltage set. And you'll also want to check your motherboard specifications and see if your voltage regulator module is one that can adjust dynamically or if you need to set it specifically yourself with those jumper settings. CPU technologies are changing rapidly these days, and you'll find as you go out to purchase new pieces of equipment that you may need a 32-bit processor or you may find there are 64-bit processors out on the market. And this refers to the amount of information that you're able to process at one time inside of that CPU. Essentially, it's how much the width is of that bus that's able to send information back and forth. And the larger bus sizes, the more information that a CPU is able to calculate simultaneously, the more data it's able to move and the more efficient that it's able to be. 64-bit obviously can move twice as much as a 32-bit. Even 32-bit processors tend to have 64-bit buses, so it's able to transfer a lot of information and use that simultaneously inside of a system. When you look at a 64-bit architecture, if you're buying a system that's a 64-bit system, like my laptop is a 64-bit processor, the software has to be optimized to take advantage of that. I'm only running a 32-bit operating system on my laptop. Even though I have a 64-bit architecture underneath, I'm not even using the full capabilities of that. And that's because the operating system that I choose to use is one that works really well in 32 bits. If I move to a 64-bit architecture with my software, then I'm going to have to make sure that everything associated with my operating system runs at 64-bit. And these days, that may not be guaranteed. So you can't just decide randomly whether you're going to get 32-bit or 64-bit. There is a set of processes you have to think about. You have to think about the operating system that's going to run on and the hardware that you're going to use so that all of the device drivers also run at 64-bit. When we start trying to compare different personal computers, different laptops, different CPUs themselves, what you're going to find is there is a difference between what the real speed of a system might be and what the actual performance of that system really is. Historically, we have always thought of CPUs as performing as a certain clock speed. We look at a 1 gigahertz system and compare it to a 1.3 gigahertz system. And we've traditionally thought that the 1.3 gigahertz system is one that performs faster. It has a higher performance. But that's not necessarily true any longer. When we look at the technology, some of them we've talked about today, with hyperthreading and multiple cores of a CPU, and understanding what the size of an L1 cache and L2 cache might be. All of those different pieces go into the overall performance of a CPU. And depending on the different settings for those, a CPU could operate differently. If you go out to Intel's website, what you're going to find is that the processor descriptions there have completely moved away from a number of clock cycles. They don't talk about their processors as a number of gigahertz or a number of megahertz any longer. They talk about their processors as having different capabilities, different sized caches, different number of cores in the CPUs. And so they have models and model numbers these days rather than looking at just one individual piece of performance in that CPU. The problem is when you want to start comparing one system to another and trying to understand the performance of one PC versus another PC. That's where it's hard because there is no broadly acceptable measure of performance. When we start trying to understand more about that, you often have to use a third-party benchmarking tool. There are a number of benchmarking programs that you can run on your system that will help you understand the overall performance. Each benchmarking software might look at a different part of the system. Some might focus on CPU performance, others might focus on graphical performance. There are a number of websites you can find if you Google for benchmarks that have already taken different benchmarks for different systems, so you can at least get a pretty good idea of what those might be. But if you want to get really, really detailed information, you're going to want to look at many different kinds of benchmarks and see how they're measured across different systems. When you start getting into more advanced capabilities of computers, or if you're someone who just likes to experiment with PCs, then you've probably heard of a technology called overclocking. This is when you tweak configurations of your system, usually you tweak those in the BIOS, to be able to get a little bit more performance out of your system. For instance, my laptop is running at 2.3 gigahertz with its processor, but what if I could increase the capabilities of my system so that CPU could run just a little bit faster? Well, when we start changing some parameters, maybe we're changing the speed of the front side bus, maybe we're changing the multiplier itself of the CPU and the way that it operates versus the crystal clock that's on our motherboard, or maybe we're changing the timings of memory. memory. Maybe we're making a change to all of those different pieces to try to get the maximum performance out of our system. And when we start doing that, we're really pushing the capabilities of a system. It's very possible when you work in an overclocking environment that you're going to create a problem with those things. You don't want to create any issues, but you're really just trying to have fun with this. This is not something you would want to do on a production system with a production server. This is more of a hobbyist type technology in the way that we use these CPUs in a system. And that's because when you start pushing the capabilities of a CPU, you could destroy the CPU. You could damage it beyond repair. You can make it get so hot that it damages itself. It's certainly often going to also shorten the life of the components because we're driving them very, very hard. So you can expect that even though that's something we're doing, it's going to require additional cooling. It may require additional fans inside of a system. And when we start doing this, you can also bet that the warranties associated with this system are going to be thrown out the window. There's no warranty when you start overclocking a CPU. And it's very obvious when you bring in a melted CPU that what you've been doing on that system. You know that there's been some overclocking going on. So something fun to play around with, but don't think that you're going to be using this overclocking technology in a production server that's going to be in your production environment. In review, we've talked about a lot of different CPU technologies today. We've talked about how hyper-threading and dual-core technologies can increase the overall speed and performance of your CPU. We've also talked about how throttling can decrease the speed of your CPU. As we go through looking at the way CPUs operate, we've got a better understanding now of how microcode and caching and these voltage regulator modules can change the way that CPUs operate. Indeed, the 32 versus 64-bit is going to be increasingly important as we go through time, and you can see how all of these things working together can really show us the differences between the real performance of a CPU and the actual performance of a CPU. And finally, we talked about how hobbyists might use CPUs and push them a little bit further through the use of overclocking. For more A+ certification training for our message boards, to get on our mailing list, feel free to visit our website at freeaplus.com.